Look at your hand again. Same hand, same color. But this time, I want you to think about it differently, because everybody has heard the why of this story, and almost nobody has heard the when. The why is easy. The why is in every textbook. Humans came out of Africa with dark skin, walked north into low sunlight, needed vitamin D, got pale, clean, tidy, fits on a slide. The when is where it gets strange, because the when is so recent it feels like a mistake. Not hundreds of thousands of years ago. Not when humans first set foot in Europe. We are talking about a transformation that was still visibly, measurably in progress while people were building cities, while there were kings. While there was written language and bronze weapons and pyramids sitting in the desert getting older by the day. There were Egyptian dynasties rising and collapsing while large parts of Europe had not finished turning pale. And I need you to understand, this isn't a theory. This isn't somebody's model or somebody's guess. We have the DNA. We have it pulled straight out of the teeth and the inner ear bones and the femurs of hundreds of specific individual human beings stretched across the last 45,000 years. We can read their pigmentation genes the same way you'd read a label. We know with real confidence roughly what color these people were. So let's put an actual clock on this thing. Let's walk it from the very beginning, decade marker by decade marker. And I promise you, the number we land on at the end is going to feel wrong. Start the clock at 1.2 million years ago. That's not us. That's not Homo sapiens. That's Homo erectus, wandering around East Africa with a brain roughly 2/3 the size of yours and a stone toolkit you could learn to make in an afternoon. And we start here because this is approximately when dark skin enters the story. Here's how we know that, and it's clever. There's a gene called MC1R that helps regulate melanin production. In modern African populations, that gene is almost eerily uniform, practically no variation, generation after generation, unchanged. And in genetics, that silence is deafening. When a gene refuses to vary, it means every mutation that ever appeared in it got deleted by natural selection, because every mutation that appeared in it got somebody killed before they could pass it on. And by measuring exactly how little variation has managed to accumulate, you can run the math backward and estimate how long that gene has been locked down. The answer comes back around 1.2 million years, which reveals something people rarely think about. Our ancestors did not become dark-skinned because they lived in Africa. They lived in Africa forever. They became dark-skinned because they lost their fur. They were pale-skinned animals wearing a coat of hair, exactly the way a chimpanzee is pale-skinned under all that fuzz. But once early humans started walking and running enormous distances across open savanna, sweating, hunting in the punishing heat of midday, the fur became a liability, and it went. And the moment the fur went, naked skin was standing there facing the full, unfiltered output of the equatorial sun with absolutely nothing in the way. Melanin was the emergency repair, and it got installed fast, and then it got welded shut for the next million years. So by the time actual Homo sapiens shows up on the scene, around 300,000 years ago, dark skin wasn't new. It wasn't a recent innovation. It was hand-me-down equipment, already a million years old, already stress-tested across a dozen ancestor species, already completely non-negotiable. Every single member of our species had it. Not most, not almost all. For the first 250,000 years of human existence, there was no such thing as a pale human being anywhere on this planet. The category didn't exist. Now let's move. Somewhere between 70,000 and 100,000 years ago, groups of humans begin leaving Africa. And I always slow down here, because people picture an event. They picture a decision, a departure, somebody standing on a hill pointing north. That is not what happened. It was drift. A band settles a little further out than their parents did. Their children settle a little further than that. Nobody was migrating. Everybody was just living slightly beyond where they were born, and it took tens of thousands of years for that to add up to a continent. They moved through the Middle East, into Central Asia, and around 45,000 years ago, they walk into Europe. And here's where the textbook version tells you the skin starts lightening. Cold place, weak sun, low UV, vitamin D crisis, so the pale variants sweep through the population, and everyone goes fair over the next few thousand years. Except we can actually check that now. And when we checked, it was wrong. There is a man we call Ust-Ishim. He lived in western Siberia, roughly 45,000 years ago. His thigh bone turned up eroding out of a riverbank, and his genome is one of the highest quality ancient genomes we have from anywhere near that period. He is essentially a high-resolution photograph of what the first humans in the far north actually looked like. Dark skin, in Siberia, 45,000 years ago. And before you write him off as one weird guy, he isn't. When researchers at the University of Ferrara ran the pigmentation genes of hundreds of ancient individuals from across Europe and Eurasia, the entire Paleolithic block came back almost completely dark. And that block is not a short window. That's roughly 45,000 years ago down to 13,000 years ago. 32,000 consecutive years. In that entire enormous span of human occupation, they found essentially one individual with anything you could call an intermediate skin tone. 1. Let that sit for a moment. Humans lived in Ice Age Europe, not mild Europe, full glacial Europe. Mammoths, cave lions, woolly rhinos, ice sheets grinding down across Scandinavia, winter sun so low and weak, it barely bothers clearing the horizon. They lived there for 30,000 years. 30,000 years is longer than all of recorded human history, multiplied by 5. Everything you have ever learned in a history class fits into the last sixth of that. And they stayed dark the whole time. So the obvious question, the one that should be bothering you right now is, why? If low UV was such a savage selection pressure, if vitamin D deficiency was supposedly bowing children's legs and killing women in childbirth, how did nothing happen for 30,000 years? There are two answers, and neither one gets enough attention. The first is that Ice Age Europeans were eating their vitamin D. These people were not farmers, they were hunters, and they were extremely good at it. Reindeer, horse, bison, mammoth, salmon, seals along the Atlantic coasts. And critically, they were eating all the parts we now throw in the trash: liver, kidney, bone marrow, brain, blubber, fat. Organ meat is absolutely loaded with vitamin D. Oily fish is loaded with vitamin D. A glacial European hunter was pulling more vitamin D out of a single good meal than most people watching this video will get all week. Their skin didn't need to change because dinner was already covering the deficit. The selection pressure everyone assumes was hammering them was largely being canceled out, not by biology, by diet. The second answer is clothing. Somewhere around 40,000 years ago, humans in the north developed genuinely sophisticated tailored clothing. We know because we find the tools: eyed needles, awls, scrapers for working hide. These weren't people draping a pelt over their shoulders. These were people sewing fitted garments, because in glacial Europe, you either did that or you died in November. But think about what that means for skin. If you are covered head to toe for 9 months of the year, your skin's UV exposure collapses to whatever hits your face and hands. And here's the twist. That cuts both ways. Yes, less UV means less vitamin D, but it also means the selection pressure on skin color itself gets weaker, because your skin has been taken out of the equation. You've replaced a biological solution with a technological one. Evolution can't optimize a variable you've covered with a coat, so the clock keeps running. 30,000 years of almost nothing. And then, around 14,000 years ago, we get the first real flicker. The ice is retreating. The climate is swinging warmer. Populations are pushing back up into northern Europe from refuges in Iberia and the Balkans and Italy, mixing as they go. And in the DNA from around this period, for the first time, the light pigmentation variants start showing up. The two big ones have deeply unmemorable names: SLC24A5 and SLC45A2. Between them, they carry a genuinely enormous share of the average difference in skin tone between modern Europeans and modern West Africans. A single change in SLC24A5 accounts for a shocking chunk of it all by itself, which is unusual. Most human traits don't have single levers like that. 14,000 years ago, those variants exist in Europe, rare, scattered, but present. The clock has finally started ticking, and then it ticks incredibly, almost insultingly slowly. Which brings us to my favorite individual in this entire story, because he short-circuits people's assumptions completely. Cheddar Man, Britain, around 10,000 years ago, found in a cave in Somerset. And when his genome was sequenced and the results came out in 2018, a lot of people were upset, which tells you more about us than about him. Dark to dark intermediate skin, dark curly hair, and blue eyes and dark skin. That combination looks impossible to a modern eye, because we have been trained to treat those traits as a bundle. Pale skin, light hair, light eyes, one package deal, comes together, goes together. Cheddar Man says absolutely not. Those traits came apart. They ran on completely separate schedules, and he isn't a fluke either. There's a Swedish hunter-gatherer from around 12,000 years ago showing the same mismatch. Dark skin, blue eyes. 10,000 years ago in Britain, the average person was dark-skinned. Not lightly tanned, not olive, dark. And that is after 35,000 years of continuous human presence in Northern Europe. Now here's the turn nobody expects. Because the thing that finally moved the needle in a serious way was not a mutation. It was an invasion. Around 9,000 years ago, farming arrives in Europe, and it does not arrive as an idea passed from village to village. It arrives as people. Agriculture was developed in Anatolia and the Fertile Crescent, and the farmers themselves physically walked into Europe, carrying wheat, barley, lentils, goats, sheep, pottery, and their own genomes. And they came in numbers that completely overwhelmed the hunter-gatherers already living there, because farmland feeds vastly more humans per square mile than hunting ground does. It's not close. And those Anatolian farmers were already carrying the light pigmentation variants at much higher frequencies than the Europeans they were walking in on. So an enormous share of Europe's depigmentation did not happen in Europe. It got imported. It walked in from the southeast, pre-installed, riding along with the wheat. What looks from a distance like a population slowly evolving in place is in significant part one gene pool being poured into another and diluting it. Europe didn't gradually change its mind about skin color. Europe got demographically replaced, twice, and the incoming groups happened to be lighter. And now the diet story finally lands with real force, because the farmers brought agriculture, and agriculture is a nutritional disaster for vitamin D. Hunter-gatherers ate liver and marrow and oily fish. Farmers ate bread, wheat, barley, rye, oats, porridge, gruel. Vitamin D content of a cereal-based diet, effectively zero. Not reduced, zero. So for the first time in the whole story, you have dense populations at northern latitudes whose diet is no longer bailing their skin out. Now the skin actually has to do the job alone. Now every marginal reduction in melanin genuinely translates into more vitamin D synthesized, better calcium absorption, denser bone, fewer children with rickets, fewer women dying in labor with a pelvis softened by osteomalacia. There's even a wrinkle involving dairy here that's worth mentioning, because it points the same direction. Farming populations start drinking milk, which is loaded with calcium, but you can't actually absorb calcium efficiently without vitamin D. So a milk-drinking, grain-eating population in a cloudy northern climate is walking around with plenty of calcium in the gut and no biochemical key to unlock it. That's not a small problem. That's a skeleton problem, generation after generation. 9,000 years ago is when the pressure finally switches on properly, not 45,000, 9. And even then, even with all of that stacked up, it is slow. Take Otzi, pulled out of an alpine glacier, lived about 5,300 years ago. Copper Age. He is a contemporary of the early Egyptian dynasties and the building of Stonehenge. He had a copper axe, tattoos, and a genome we've read in detail. His skin was darker than that of modern Southern Europeans. Not equatorial dark, but darker than the people living in that same alpine valley today. 5,000 years ago, in the mountains of Central Europe, we are still not there. Push forward into the Copper and Bronze Ages, roughly 7,000 to 3,000 years ago. Light pigmentation keeps climbing. Bronze Age populations show a real, statistically solid increase in lighter complexions, and you start seeing pale individuals clustering in Central and Northern Europe. But across the sampled individuals from this whole period, roughly half still come back dark, or intermediate, half, in the Bronze Age. When there were chariots, and bronze swords and cuneiform tablets, and the Great Pyramid was already more than 1,000 years old, and starting to look weathered. The tipping point finally lands in the Iron Age, roughly 3,000 to 1,700 years ago. That's the last 3 millennia. That's the era of Homer, the Assyrians, the Persians, the founding of Rome. It is in that window that light skin finally becomes about as common as dark skin across Northern and Central Europe. And even then, it's patchy. Dark pigmentation stays common in Italy, in Spain, in Russia. There were plenty of dark-skinned Europeans walking around during the Roman Republic, not as travelers, not as visitors, as locals, as the ordinary descendants of families who had been on that land for 30,000 years. So here is the actual answer to the question in the title. The shift from dark to light skin in Europe was not a moment. It was a process that cracked open around 14,000 years ago, got seriously underway around 9,000 years ago, and only crossed the halfway line something like 3,000 years ago, which means the pale European phenotype, the thing that got used for centuries as evidence of some deep, ancient, essential category of human being, is younger than the wheel, younger than writing, younger than the pyramids, younger than domesticated horses, younger than beer. In the 300,000-year history of our species, it is the last 1%. And I want to press on one more thing, because the researchers doing this work were careful to say it, and it genuinely matters. This change was not linear. It didn't tick smoothly upward like a thermometer. It went in fits and starts. It surged in some regions and completely stalled in others. Some populations got lighter and then got mixed back darker by the next wave of arrivals. Selection was real, vitamin D was real, but so was migration, and so was plain dumb luck. Genetic drift, small populations, random survival, which variants happened to be sitting in the group that made it through a bad decade. This wasn't a clean adaptive story arc, with a beginning and an end. It was a mess. It was accidents and invasions and diets and dice rolls that happened over enough time to land in a particular direction. And just to hammer home how independent these traits are from each other, let's run the clock on blue eyes separately, because it doesn't match the skin clock at all. Blue eyes trace back to a change near a gene called OCA2, driven by a switch in a neighboring gene called HERC2, and the estimates put the origin somewhere around 6,000 to 10,000 years ago, in the general neighborhood of the Black Sea. Before that individual was born, every human being on Earth had brown eyes. Every one. All the way back through every ancestor species, every hominin. Brown, brown, nothing but brown. Then one person is born with a change that throttles melanin production specifically in the iris, and every blue-eyed person alive today descends from them. But as Cheddar Man already showed us, that variant was spreading merrily through populations that were still dark-skinned. Two traits, two clocks, two completely different speeds. And Europe is only one branch of this. East Asia ran an entirely separate experiment. East Asian populations also have significantly lighter skin than equatorial African populations. Same environmental math, same low UV latitudes, same vitamin D problem. But the genetic variants doing the work are largely different ones. Different genes, different mutations, different timeline entirely. Europeans and East Asians did not inherit light skin from some shared pale ancestor. They evolved it separately, independently, from scratch, using different molecular tools, and arrived at a similar-looking destination down completely different roads. That's convergent evolution, and it is the strongest signal biology ever gives you that a problem was real. When natural selection has to solve the same puzzle twice, in two places, with two different sets of parts, it means the puzzle mattered. There's even a genuinely odd footnote here involving Neanderthals, who were living in Europe for hundreds of thousands of years before we showed up, and who may well have carried light pigmentation variants of their own. Which would mean that for a long stretch of Ice Age Europe, the pale hominins were the Neanderthals, and the dark-skinned newcomers walking into their territory were us. So let's land this. The question was when. And the honest answer is, astonishingly late, unevenly, and substantially by accident. Dark skin is the default. It is over 1 million years old. It is the setting our species shipped with, and it stayed the setting for the overwhelming majority of human existence, including 30,000 years of humans living under Ice Age skies in Northern Europe without meaningfully changing at all, because they had good food and warm coats and didn't need to. Light skin is the modification. It is recent. It is patchy and regional. It arrived in Europe as much by migration as by mutation. It needed the invention of farming to really get moving, and it did not become the majority condition of the continent until an era we have written records for. Every trait we treat as fixed and ancient and defining, skin tone, eye color, hair color, turns out to be a live experiment that was still visibly running while people were already building empires. There was no original type. There was no finished version. There is only a long chain of populations adjusting to sunlight and to diet and to each other, one generation at a time, with no idea they were doing it. And that chain is still running right now. We just muffled the signal beyond recognition. We have supplements, fortified milk, sunscreen, salmon, flown 4,000 miles in February. Every environmental pressure that shaped every one of these traits has been dismantled and replaced with one we built ourselves. We have the DNA of the last 45,000 years. We know exactly how the story went. We have absolutely no idea what the next 3,000 years look like.